I am Ucioma Garza Vidal, Jose Luis Jimenez Perez, Sanchez Ramirez Jose Francisco, and Correa Pacheco Sormi, and we are to present to you thermal study of magnetic nanofluid using two photothermal techniques for hyperthermic application in biomedicine. First, the importance of the thermal characterization of nanofluids has been important in the field of heat transport for hyperthermic application for the localized treatment of cancer based on the exposure of magnetic nanoparticles to an external fields. Introductions. There are different reports on the use of photothermal techniques in the measurement of thermal parameters of ferromagnetic nanoparticles. For example, the Horia studied the effect of the size and optical properties of these nanoparticles. Also, the technique of photoacoustic was used to determine diffusivity and effusivity. We use two kinds of methodologies. One is called TWRC, that consists in a diode laser beam modulated at a frequency of 0.25 Hz. At this modulated instead in a thin aluminum foil, think mounted on an automatic micrometer linear state controlled by a PC. The modulated light was absorbed into the thin, highly conductive aluminum foil, which acts as an optical to thermal energy converter. The cylinder module was immersed in a sample that it shows in the figure 1. To obtain the thermal diffusivity of the sample, the complex equation that is called equation 1 was fed to the amplitude and phase to the experimental data or the frequency that you can see. Also, the another technique that we use is called thermal lens technique, that consists in a Gauss profile laser source, the laser as an excitation source. The absorption of the optical energy by the sample is converted into the heat. Therefore, after a time interval, the sample undergoes a non-radioactive relaxation process. In this relaxation process, there is a change in the temperatures and a change in a reflective index, which can detect as a convergence or divergence like beam. And another laser that is called laser test. After measuring for the region where the sample is found, the signals of the lens obtained in the sensor is given by the equation 2. The precision methodology was false, that is that we create or synthesize the nanoparticles. For example, 1 gram of ferrous salts that called iron sulfate hyperhydrate was dissolved in 100 milliliters of distilled water at a temperature of 80 centigrade with a speed of 1000 rpm using a non-magnetic stirrer. Then 10 milliliters of hydroxodium is added drop side until a pH is 10, and we left for 10 minutes, and then stirrer was removed and allowed to color temperatures. We filter and wash this with water and ethanol at least 5 times until the pH is neutral. And the results and discussions. The FT-ER spectrum of iron oxide is shown in the figure 3. It shows strong bands in the low frequency region from 1000 to 500 due to the iron oxide skeleton, which is considered with the spectrum magnetic. The strong absorption band concerns approximately between 580 and 519 confirm that the main phase of the synthesized particles is magnetism, ascending into the vibration mode and torsion mode of these bonds. Also, we found all the reflection peaks, that is 220, 311, 400, 422, 422, 511 can index well in the inverse cubic spin structure of magnetism of this magnetism, according to the position of the reflection peaks and the relative intensity. Is confirmed that the nanoparticles synthesized in these studies are magnetic nanoparticles. Also, test for hyperthermia in magnetic samples with a magnetic field induction and a pulse laser. We can see the thermal spectrum, and also in the image, in the left image, we can see the camera and also the magnetic fields that is with a magnetic liquid. On the right, we can see field nanoparticles, and we excite with a laser, and also we create a hat. The results obtained by the TRC techniques are agreement with the results of the thermal lasers. The measurement of the TWRC techniques are slower and is more sensitive techniques compared to the thermal laser technique that is more versatility faster and can detect traces of a ppm for semi-transparent samples. And also we can see the measurements in the tables, and also the the signals of the TWRC and thermal length signals. Conclusion: the TWRC and thermal length spectroscopy techniques were used for the study of the experimental optical thermal parameters such as thermal diffusivity. The advantage and disadvantage of each technique were discussed. First, the thermal diffusivity of magnetic nanoparticles were measured by two techniques, obtaining similar results for the measurement reports for small concentration and different for those higher than 0.4 milligrams per millimeter. These two thermal techniques were compared. So the TWRC technique were more efficient for non-transparent samples with a high concentration, different thickness. And also we have the reference, and that's all. Thank you for your listening, and